welcome to the deep dive. Today we're diving into Azure Cloud Security.
Yeah.
But specifically for someone who's maybe new to this whole world.
Yeah, it's a big topic, and it's so important these days, with everybody moving to the cloud. It's
Yeah.
understanding how to secure your Azure environment is really crucial.
Absolutely. And even for people who've been working with Azure for a while, the scope of the security tools that Azure offers can be kind of overwhelming.
Yeah.
Right? There's just so much there. So we're going to kind of break it down today and really focus on the fundamentals. And hopefully by the end of this deep dive, you'll have a better grasp of how to approach Azure security.
Right.
And some of the key things to consider. And one of the things that I always find fascinating about Azure security is that you can actually keep your data encrypted while it's being used.
Right.
Not just when it's at rest, which is pretty amazing.
Yeah, it's really cool. And it's it's all about protecting your applications and your data ultimately.
Absolutely.
Yeah.
So let's start with the basics. When we talk about cloud security, there's always this concept of shared responsibility.
Right.
Right. So what does that mean in the context of Azure? Like, what's Microsoft responsible for, and what are we as the users responsible for?
So it's kind of like renting an apartment, right? Microsoft is the landlord. They're responsible for the security of the building itself, the physical infrastructure.
Okay.
But you, as the tenant, you're responsible for securing your own apartment.
Yeah.
Locking your doors and windows and making sure that your belongings are safe.
Got it. So Microsoft takes care of the underlying infrastructure, the hardware, the data centers, all of that.
Right.
And we're responsible for securing our own stuff within that environment.
Exactly. And it's important to remember that Azure is a multi-tenant environment. So you've got millions of customers all sharing the same infrastructure.
Right. Yeah.
So Microsoft has to have incredibly robust security measures in place to make sure that everybody's data and applications are isolated and protected.
That's reassuring to know.
Right.
Especially when you think about the sheer scale of Azure.
Yeah.
Right. It's massive.
Yeah.
So Microsoft's got the city walls and the security guards, but we still need to lock our own doors and windows.
Exactly. And the good news is that Azure gives you a lot of flexibility and customization options.
Oh, good.
So you can tailor the security settings to meet your organization's specific requirements.
So we're not stuck with just a one-size-fits-all security model.
Right.
We can actually adapt the security controls to fit our needs and our risk tolerance.
Exactly. You have a lot of control over how you implement security in Azure.
Okay, so we have this shared responsibility model, and we have this highly secure and scalable platform to build on.
Right.
So how do we even begin to approach security in such a vast and complex environment?
Well, Azure has this framework called the 6 Pillars of Azure Security.
Okay.
And it breaks down security into 6 key functional areas: operations, applications, storage, networking, compute, and identity.
Okay, so 6 pillars holding up the whole security structure.
Yeah, think of them as the foundational elements of a secure Azure environment.
Got it. And each pillar has its own specific security considerations and best practices.
Exactly. And by focusing on each of these pillars, you can create a really comprehensive and layered security posture in Azure.
Okay, so let's start with the first pillar, operations. What does that encompass?
So operations is all about monitoring and managing the security of your Azure environment.
Okay.
It's like having a security operations center or a SOC that's constantly watching for threats and responding to incidents.
Okay, so it's the eyes and ears of our Azure security setup.
Right.
What kind of tools and services does Azure provide for operational security?
Well, one of the most powerful tools is Microsoft Sentinel.
Okay.
Think of it as a SIEM system on steroids. It uses AI and machine learning to analyze massive amounts of security data, looking for patterns and anomalies that might indicate a threat.
So it's like having a super smart security analyst who can sift through mountains of data and spot those subtle clues that humans might miss.
Exactly.
That sounds incredibly valuable.
It is. And Sentinel can also automate a lot of the tasks involved in incident response, like isolating infected machines and blocking malicious traffic.
Wow. It's like having an automated security team working 24/7.
Yeah, pretty much.
To protect our Azure environment. What other tools are commonly used for operational security?
Another key tool is Microsoft Defender for Cloud.
Okay.
It acts as kind of a security advisor and a policy enforcer. It continuously assesses your Azure resources for vulnerabilities and provides recommendations for improving your security posture.
So it's like having a security consultant built right into the platform.
Yeah, exactly.
That's fantastic. Does it just provide recommendations, or can it actually enforce security policies as well?
It can definitely enforce policies.
Okay.
You can define your own security policies based on industry best practices or regulatory requirements.
Okay.
And Defender for Cloud will make sure that your Azure resources comply with those policies.
So it's like having a security guard who not only spots potential problems, but also steps in to fix them.
Mm,
That's a huge help, especially for organizations that might not have dedicated security staff.
Absolutely. Defender for Cloud can take a lot of the guesswork out of security management.
Okay, so we've got Microsoft Sentinel for threat detection and response, and we've got Microsoft Defender for Cloud for security assessment and policy enforcement.
Mm.
Are there any other tools that are commonly used in operations?
Yeah, Azure Resource Manager or ARM is essential for deploying and managing your Azure resources securely.
Okay.
It uses templates to define your infrastructure and configuration, which helps to automate deployments and ensure consistency.
So it's like having a blueprint for your Azure environment, which helps to avoid manual errors and ensure that everything is set up securely from the start.
Exactly. And ARM also integrates with other Azure security services like Azure Policy, which allows you to define and enforce security policies at scale.
Okay. And speaking of monitoring, what are some of the key tools that Azure provides for keeping an eye on security events and activities?
Well, Application Insights is great for monitoring the performance and security of your web applications. It can track metrics like response times, error rates, dependency calls, and it can also detect suspicious activity like SQL injection attempts and cross-site scripting attacks.
So it's like having a dashboard that shows us how our web apps are performing and whether they're under attack.
Exactly.
That's incredibly valuable for developers and security teams.
Absolutely. And for a more comprehensive view of your entire Azure environment, you can use Azure Monitor.
Right.
It collects and analyzes telemetry data from a wide range of sources, including your Azure Resources applications and even on-premises infrastructure.
Wow. So we can get a holistic view of our entire IT landscape, both in the cloud and on-prem.
Right.
That's impressive. What kind of insights can we glean from Azure Monitor?
Azure Monitor can alert you to security events, performance issues, operational anomalies.
Okay.
It can help you track resource utilization, identify cost optimization opportunities, and troubleshoot problems quickly.
So it's not just a security tool, it's an overall operational intelligence platform.
Right.
That's fantastic. Any other operational tools that you think are worth mentioning?
One more I'd recommend is Azure Advisor.
Okay.
It's like having a personal consultant for your Azure environment. It analyzes your configuration and usage patterns, and then offers recommendations for improving performance, security, and cost efficiency.
So it's proactively helping us to optimize our Azure deployments and avoid potential problems.
Exactly.
That's really valuable.
It is. Azure Advisor can even help you identify unused resources and recommend ways to reduce your Azure spending.
All right, so we've covered a lot of ground in this first pillar, operations. It's clear that Azure provides a really robust set of tools and services for monitoring, managing, and responding to security events. I'm starting to see how these tools can help organizations build a really strong foundation for security in the cloud.
Yeah, it's a great foundation. It's a great foundation. And like you said, there's a lot more to explore. But what's important is that you're starting to see how these tools can all work together to create a really comprehensive security strategy.
Definitely, I'm starting to feel a bit like I'm building a security fortress in the cloud. But let's move on to the next pillar, applications. It feels like this is where things start to get really interesting.
Absolutely. Securing applications in the cloud requires a bit of a shift in mindset.
Okay.
It's not just about protecting the infrastructure anymore. It's about building security into the very fabric of your applications.
So we're not just securing the castle walls, we're also training the knights inside to defend themselves.
Exactly.
Where do we even begin with securing applications in Azure?
Well, even in the cloud, you can't forget about the basics. Penetration testing is still incredibly important.
Okay.
It's like having a friendly hacker try to break into your application before the bad guys do, so you can find and fix any vulnerabilities.
That makes sense. But I imagine penetration testing in the cloud can be a bit tricky. Do we need special permissions from Microsoft to do that?
Absolutely. Azure has very clear rules of engagement for penetration testing. You need to get authorization from Microsoft before you start poking around, and you need to follow specific guidelines to make sure that you're not affecting other Azure customers.
Okay, so responsible hacking is still the name of the game.
Right.
Once we've identified vulnerabilities through penetration testing, what are some of the tools and techniques we can use to protect our applications in Azure?
One of the most powerful tools is the Azure Web Application Firewall, or WAF for short.
Okay.
Think of it as a shield that sits in front of your web applications, blocking malicious traffic, and protecting against common attacks like SQL injection and cross-site scripting.
So it's like a security checkpoint for our web applications,
Right.
making sure that only legitimate requests get through. That's reassuring. But how does the WAF know which traffic is good and which traffic is bad?
The WAF uses a set of rules to analyze incoming traffic and identify patterns that are indicative of attacks. These rules can be customized based on your application's needs, and Microsoft keeps them updated with the latest threat intelligence.
So it's not just a static set of rules, it's actually learning and adapting to new threats as they emerge.
Exactly.
Yeah.
The WF is designed to be a very dynamic and intelligent security layer for your web applications.
That's impressive. What about securing user access to our applications? That's got to be a critical piece of the puzzle.
You're absolutely right. Authentication and authorization are fundamental to application security.
Right.
And Azure makes it surprisingly easy to implement secure user sign-in with a feature called App Service Authentication Authorization.
Okay, tell me more about that. How does that simplify things for developers?
Well, it handles all the complex plumbing of user authentication and authorization for you.
Okay.
You don't need to write a ton of custom code to handle things like user registration, password management, multi-factor authentication, all that stuff.
So it's like having a pre-built security module that we can just plug into our applications.
Exactly.
That sounds like a huge time saver.
It is. And it supports a wide range of identity providers, including Azure Active Directory, Facebook, Google, Twitter, and more.
So we can give our users the flexibility to log in with the accounts they already use.
Right.
That's great for user experience.
Exactly. And because App Service Authentication Authorization is a managed service, Microsoft takes care of all the security patching and maintenance for you.
That's one less thing for us to worry about. Are there any other tips or best practices for securing applications in Azure?
Absolutely. One key principle is to design your applications with security in mind from the very beginning.
Good.
Don't treat security as an afterthought.
Okay.
Think about potential threats and vulnerabilities early in the development process.
Okay.
And build security into every layer of your application.
So it's a shift-left approach to security,
Exactly.
integrating it into the entire development lifecycle.
Right. And another important concept is defense in depth or layered security. Think of it like building a castle with multiple walls and moats.
Okay, I like that analogy.
Each layer of security makes it harder for attackers to penetrate your defenses.
So how do we actually implement layered security for our applications in Azure?
Well, Azure provides a range of tools and services that you can use to create a layered security architecture. For example, you can use app service environments to isolate your web applications from other tenants on the Azure platform.
Okay.
You can use network security groups to control traffic flow between different parts of your application. And you can use virtual networks to create isolated network segments for your applications.
So it's like we're creating a series of concentric rings of security around our applications.
Yeah.
Making it much harder for attackers to reach our most sensitive data.
Precisely.
Yeah.
And by combining these different security layers, you can create a really robust and resilient security posture for your applications in Azure.
This is all starting to make a lot of sense.
Yeah.
But I have to admit, I'm starting to get a little worried about how much responsibility we have as users to secure our applications and data in Azure.
Yeah.
It's a lot to think about.
I understand your concern. But remember, you don't have to do it all alone.
Okay.
Microsoft provides a wealth of resources and support to help you navigate the complexities of cloud security.
That's good to know. But even with all these tools and resources, I can't help but feel a little overwhelmed. Where do we go from here?
Well, I think the key is to start small and focus on the fundamentals. Don't try to implement every security feature at once.
Okay.
Instead, identify the most critical assets and data in your Azure environment and start by securing those.
So it's a gradual process of building up our security posture over time.
Exactly. And remember, security is an ongoing journey, not a destination.
Right.
There will always be new threats and vulnerabilities to address. The key is to stay informed, be proactive, and continuously adapt your security strategy to meet the evolving threat landscape.
All right. I'm feeling a bit more confident now. We've covered a lot of ground on application security, and I'm starting to see how you can use Azure's tools and services to build secure and resilient applications in the cloud.
That's great. And now that we've talked about securing our applications, let's move on to the next pillar, storage. This is where we really get into the heart of protecting our most valuable asset, our data.
Okay, let's dive into data security. It's probably the topic I'm most concerned about when it comes to the cloud. How do we even begin to wrap our heads around securing data in a vast and distributed environment like Azure?
It can seem daunting at first, But Azure offers a really robust set of tools and services that can help you protect your data throughout its lifecycle, both in transit and at rest. One of the fundamental principles of data security is access control. You need to make sure that only authorized users and applications can access your data.
That makes sense. So how do we actually manage access control for our data in Azure?
That's where Azure Role-Based Access Control, or RBAC, comes in.
RBAC. Pretty self-explanatory, controlling access based on roles. But how does that actually work in practice?
Think of it like this. Instead of giving everyone the keys to the kingdom, you're assigning specific permissions based on someone's job function.
Okay.
You wouldn't give your accountant access to your customer database.
Right. Right.
RBAC lets you create roles like storage account contributor or blob reader
Yeah.
and assign them to specific users or groups.
So it's all about granting the bare minimum access necessary.
Exactly. What security folks call the principle of least privilege.
Principle of least privilege. Got it.
Yeah. And this is especially important in a cloud environment where you might have hundreds or even thousands of users accessing your resources.
That makes sense. What about situations where you need to give someone temporary access to specific data, like say a contractor needs to work on a project for a limited time?
That's a great question. For those scenarios, Azure offers shared access signatures, or SAS. These are like temporary access passes with an expiration date and very specific instructions.
So kind of like giving someone a guest pass to your gym?
Exactly. It only works for a certain amount of time and only grants access to specific areas.
Yeah.
You can use SAS to define precisely what someone can access for how long and even what actions they can perform, all without sharing your actual storage account keys.
That's really cool. So it's like a secure way to collaborate without compromising the entire storage account.
Exactly.
Now let's shift gears a bit and talk about protecting data when it's moving around.
Right.
What security experts call data in transit.
Okay.
What does Azure offer in terms of encryption in transit?
This is where encryption protocols like HTTPS come into play.
Yep.
Azure Storage uses HTTPS by default to encrypt data as it moves into or out of storage. You're probably familiar with HTTPS from secure websites. It's that little lock icon in your browser's address bar.
Right. HTTPS means our data is scrambled up and unreadable as it travels across the internet.
Exactly. And if you're using Azure File Shares, there's also SMB 3.0 encryption, which is like an extra layer of security specifically for file sharing.
Okay, so HTTPS for everything is a good rule of thumb.
Absolutely. You want to make sure that all communication with your Azure storage accounts is encrypted.
Okay. Now, we've talked about data in transit, but what about when it's just sitting there in storage, what's known as data at rest?
Okay.
Right? Because even if someone can't intercept the data while it's moving, they could still potentially access it if it's just sitting there in the cloud, unencrypted.
That's a valid concern, and that's why encryption at rest is so important. It's like having a security guard watching over your data, even when it's not being actively used. Azure offers a few different ways to achieve this.
Okay. Tell me more about these different encryption at rest options. What are they and how do they work?
One option is storage service encryption, which is like a master switch that automatically encrypts data as it's written to storage. You don't have to do anything special, it just happens behind the scenes.
Okay.
Then there's client-side encryption, where you actually encrypt the data before sending it to Azure, giving you even more control over the encryption process. And for virtual machines, there's Azure Disk Encryption, which encrypts the entire virtual machine disk, including the operating system and data disks.
Wow. It's like Fort Knox for our data. We've got access control encryption, in-transit encryption at rest. What else should we be thinking about when it comes to securing our storage in Azure?
Well, it's important to keep an eye on what's going on in your storage account. That's where storage analytics comes in. Think of it like a security camera system for your data.
Oh, so we can see who's accessing what, when, and how.
Exactly. Storage analytics logs all the activity happening in your storage account, giving you metrics to track usage, analyze trends, and troubleshoot issues.
Okay.
But from a security perspective, it's a powerful tool for detecting anomalies and potential threats.
So if someone is trying to brute force their way into our storage account or access data, they shouldn't be, storage analytics will flag that activity.
Exactly. It's like having an early warning system that can alert you to suspicious activity before it turns into a major breach.
Got it. Now, before we move on from storage security, there's one last thing I want to touch on.
CoreS.
Okay. Now, that's one I haven't heard of before. Fill me in, what is CORS and why is it important for storage security?
CoreS stands for Cross-Origin Resource Sharing. It's a web browser security mechanism that controls which websites are allowed to access resources in your storage account. It might sound a bit technical, but it's essentially about preventing malicious websites from interacting with your data.
So if I'm building a website and I want to use images stored in my Azure storage account, I need to make sure CORS is configured correctly to allow my website to access those images.
Precisely. Chorus acts like a gatekeeper, making sure that only authorized websites can interact with your storage resources.
Hmm.
It's an important layer of defense, especially if you're exposing your storage account to the public internet.
Okay, that makes a lot of sense. It's like setting up specific permissions for different websites, so only the ones you trust can access your data. We've covered a lot of ground here with storage security, from controlling access and encrypting data to monitoring activity and managing web interactions. I'm already feeling much more confident about storing data in Azure.
That's great to hear. But remember, storage security is just one piece of the puzzle. Now that we've locked down our data at rest and in transit, it's time to shift our focus to securing the network itself.
All right, let's dive into the world of network security. What are some of the first things we should be thinking about when it comes to securing our network in Azure?
The foundation of any strong security posture, whether in the cloud or on premises, is network access control.
Okay.
It's like setting up a security checkpoint at the entrance to your network and deciding who and what can come in and out.
Okay, so network access control is our first line of defense. What tools does Azure give us to manage this?
One of the most fundamental tools in Azure's network security arsenal is network security groups, or NSGs for short. They're like virtual bouncers standing guard at the perimeter of your virtual network.
So NSGs control what traffic is allowed in and out of our network.
Yeah.
But how do they actually work? Do we have to manually check every single packet of data that tries to enter?
Not quite. NSGs work by defining a set of rules based on IP addresses, ports, and protocols. It's like creating a guest list for your network. Only those with the right credentials are allowed in.
So if I only want to allow web traffic to my web servers, I can create an NSG rule that only permits traffic on ports 80 and 443, which are the standard ports for HTTP and HTTPS.
Exactly. And you can create as many rules as you need to control the flow of traffic to and from your resources. It's a powerful way to segment your network and isolate sensitive applications.
That's really cool. It's like having fine-grained control over the network traffic, making sure that only the right packets are getting to the right destinations.
Yeah.
But our NSGs are only line of defense when it comes to network security.
They're a great starting point, but for more robust protection, Azure offers the Azure Firewall. Think of it as a more advanced cloud-native firewall solution that provides enterprise-grade security features.
Okay, so if NSGs is the bouncers, Azure Firewall is like having a whole security team with guard dogs.
I like that analogy. Azure Firewall goes beyond basic port and protocol filtering, offering features like application-level filtering, intrusion detection, and prevention, and even integration with threat intelligence feeds.
Intrusion detection and prevention. That sounds pretty intense. What exactly does that involve?
It's like having a team of cybersecurity experts constantly analyzing network traffic for suspicious patterns. Azure Firewall can identify and block known attack signatures, as well as detect anomalies that might indicate a zero-day attack.
So it's not just about blocking traffic based on predefined rules. It's about actively analyzing traffic and looking for signs of malicious activity.
Precisely. And Azure Firewall offers different tiers of service to meet your specific security needs.
Okay.
The standard tier is a great option for basic protection, while the premium tier provides those advanced intrusion detection and prevention capabilities we just discussed.
Got it. So we've got NSGs as our first line of defense and Azure Firewall as our more robust intelligent security layer.
Right.
But sometimes, even with all these controls in place, you might need even more granular control over how traffic is routed within your network. And that's where route control and forced tunneling come in.
You're absolutely right. NSGs and Azure Firewall are fantastic for filtering traffic, but route control gives you the power to define custom paths for network traffic within your Azure environment. It's like having a traffic management system for your network.
So instead of letting traffic wander freely, we're setting up specific paths for it to follow. What's the security advantage of that?
Imagine you have a branch office connecting to your Azure network.
Okay.
With route control, you can create custom paths for traffic to and from that branch office, ensuring it follows specific security policies. And forced tunneling is a specific type of route control that's particularly useful for security.
Forced tunneling. The name sounds a bit intimidating. Can you break down what it does and why it's important?
Think of it this way. Forced tunneling ensures that all traffic leaving your Azure VMs, even traffic destined for the public internet, is routed through your on-premises security appliances. So even if our VMs are in the cloud, we can still force their traffic to go through our physical firewall back at the office.
It might seem counterintuitive in a cloud environment, but it gives you a centralized point of control for security inspection.
So we can apply our existing security policies and monitoring tools to all traffic, regardless of where it originates. That's pretty powerful. Even with all these controls, NSG's Azure Firewall Route Control, we still need specialized security features.
In those cases, you might consider deploying virtual network security appliances, or VNSAs. They're like bringing in specialized security experts to handle specific threats.
NSGs are the bouncers. Azure Firewall is the security team. VNSAs are like having, I don't know, a cybersecurity SWAT team on call.
VNSAs can provide advanced functionalities that go beyond what's offered by the built-in Azure security features. Think intrusion prevention systems that proactively block known attack patterns, or deep packet inspection that analyzes the actual contents of network packets for malicious code. Okay, so VNSAs give us that extra layer of protection for really specific threats or security requirements. Now, I'm curious about the network itself. You keep talking about virtual networks, but what exactly are they?
An Azure Virtual Network, or VNet, is basically your own private network within Azure. It's like having a fenced-off area within the larger Azure cloud, where you have complete control over everything: IP addresses, DNS settings, security policies, the whole shebang.
Okay,
Yeah.
so it's like having our own private little neighborhood within the bigger city of Azure. We get to set the rules and control who comes and goes.
Exactly. VNets allow you to segment your resources and create isolated environments, which is a fundamental security best practice. You can even connect your VNet to your on-premises network, extending your existing security perimeter to the cloud.
That's really cool.
Yeah.
But what if you're dealing with lots of VNets, like a whole bunch of these private neighborhoods? How do you manage security at that scale?
That's where Azure Virtual Network Manager steps in.
Okay.
It's a relatively new service that lets you centrally manage and secure VNets across your entire Azure environment.
So it's like having a city planner who oversees all the different neighborhoods and makes sure they're all secure and following the rules.
Precisely. Virtual Network Manager allows you to define and enforce security policies, manage connectivity, and monitor the health of your VNets from a single pane of glass. It's a game changer for organizations with complex network topologies.
That sounds incredibly helpful, especially for larger organizations with a lot of moving parts in the cloud. But what about situations where we need to access Azure services without exposing our network to the public internet? Is that even possible?
Absolutely. That's where Azure Private Link comes in.
Yeah.
It's a service that enables private connectivity to Azure services and customer-owned services, all within the security of your own VNet.
Okay, I'm intrigued. Tell me more about these private connections. How do they work and why are they more secure?
Azure Private Link relies on something called private endpoints.
Okay.
These endpoints are like dedicated network interfaces within your VNet that connect directly to Azure services.
So instead of going through the public internet, our traffic stays within the Microsoft network.
Exactly. Since your traffic never leaves the Microsoft Azure backbone network, it's much more secure than traversing the public internet.
Okay.
And it also simplifies your network architecture since you don't need to manage public IP addresses or complex routing configurations.
This is amazing. We've got private networks, central management, secret tunnels. What else is there to know about connecting to our VNets from the outside world?
Well, we have two main options for that: VPN gateway and express route.
Okay, break it down for me. What are these gateways and routes all about?
A VPN gateway is like a secure tunnel that connects your on-premises network to your Azure VNet. It's like building a secure bridge between your physical office and your cloud network. Data traveling across this bridge is encrypted, so it's protected from prying eyes.
So if VPN gateway is a secure bridge, what's ExpressRoute? Is it like a superhighway?
You could say that. ExpressRoute is a dedicated private connection to Azure. It's like having a direct fiber optic cable running from your on-premises network to the Azure data center.
Wow. That sounds seriously fast and secure. When would we choose ExpressRoute over a VPN gateway?
ExpressRoute is typically used when you need higher bandwidth, lower latency, and even more robust security than a VPN can provide. It's often the preferred choice for mission-critical applications or large data transfers.
This is blowing my mind. We've covered so much ground in network security, from basic network controls to private connections and superhighways. I feel like we've built a real fortress around our Azure resources.
We have. And while it might seem less a lot to take in, remember that Azure provides a layered approach to security. You can start with the basics and gradually add more advanced features as your needs evolve.
That's really reassuring to know that we don't have to become security experts overnight to start building a secure cloud environment.
Exactly. And the best part is Azure is constantly evolving, adding new security features and services all the time. One of the key players in the Azure Application Gateway. Think of it as a smart traffic cop that sits in front of your web applications. It not only distributes incoming traffic across multiple servers, but it also provides a ton of security features.
Okay, hold on a second. Azure Load Balancer, didn't that also distribute traffic? What's the difference between these two?
You're right to point that out. Azure has a few different balancers, and it can be a bit confusing at first. Azure Load Balancer operates at layer 4 of the networking model. It's like a basic traffic cop, mainly focusing on IP addresses and ports to distribute traffic across healthy servers.
So it's great for keeping our applications up and running by making sure traffic is always going to a server that's working properly.
Exactly. But Application Gateway operates at layer 7, which means it can understand HTTP and HTTPS traffic. It's like a much smarter traffic cop that can not only direct traffic, but also inspect it for security threats.
Ah, so it's like having a security guard at the door who can check IDs and make sure only authorized individuals are entering.
Perfect analogy. This allows Application Gateway to perform TLS termination and web application firewalling, which are two crucial security features.
Okay, I'm going to need a little more explanation on those. What exactly do TLS termination and web application firewalling involve?
Sure. TLS stands for Transport Layer Security, and it's the protocol that encrypts communication between a web browser and a web server. TLS termination means that Application Gateway handles the encryption and decryption of HTTPS traffic, offloading that task from your web servers.
Got it. So it's like having a dedicated receptionist who handles all the secure communication, freeing up our web servers to focus on their main job, which is running our applications.
Exactly. Now, Web Application Firewalling, or WAF, is a built-in feature of Application Gateway that protects your web applications from common attacks like SQL injection and cross-site scripting.
Okay, those sound like some serious security threats.
Yeah.
Can you explain what those attacks are and how WAF protects against them?
Imagine a hacker trying to break into your application by sneaking malicious code into a web form. SQL injection is a technique that exploits vulnerabilities in your application's database, potentially allowing the attacker to steal data or even take control of your entire database.
That's scary. So how does WAF stop this from happening?
WAF is like a filter that analyzes incoming web traffic and blocks any requests that match known attack patterns. It can identify and block malicious code before it even reaches your application, preventing the attack from succeeding.
So it's like having a really good spam filter, but for web attacks.
Exactly. WAF is a critical layer of defense for any web application, and Azure Application Gateway makes it incredibly easy to implement.
This is great. So we've got Application Gateway handling load balancing and providing some serious security features. But what about making sure our applications are always up and running? What if one of our servers crashes or there's a network outage?
That's where Azure Traffic Manager comes in. It's like a global traffic coordinator sitting above your application infrastructure and making decisions about where to send user traffic.
So if one of our web servers goes down, Traffic Manager automatically routes traffic to a different server.
Precisely. This helps ensure that your application stays available even in the face of failures. It's a key component of building resilient and highly available application.
Okay, so we've got Application Gateway providing security and Traffic Manager ensuring availability. But we also touched on DNS earlier in the network security discussion. How does DNS play into application security?
DNS, or domain name system, is what translates human-readable domain names into IP addresses that computers understand. It's essentially the phone book of the internet. And just like a phone book can be tampered with, DNS can be a target for attacks.
So someone could hijack our DNS and redirect our users to a malicious website that looks like our legitimate site.
It's a real threat, and it's called DNS spoofing or DNS cache poisoning.
That's scary. So how do we protect against DNS attacks in Azure?
Azure offers two main options for managing DNS: internal DNS and Azure DNS. Internal DNS is for managing DNS resolution within your VNet. It's like having a private phone book for your internal resources. Azure DNS is for hosting your public DNS domains on Azure's global infrastructure.
So internal DNS is for keeping things organized inside our virtual network, and Azure DNS is for making sure our public website is accessible and secure.
You got it. Azure DNS offers high availability security and fast performance, protecting you against attacks like DNS hijacking.
That's a relief. So we've got a handle on load balancing, the wave traffic management, and DNS.
Yeah.
But how do we know if all these security measures are actually working?
Absolutely. Azure provides a wealth of monitoring tools, including Azure Monitor logs for NSGs. Remember those network security groups we talked about earlier?
Right, the virtual bouncers that control traffic flow at the network level.
Exactly. Azure Monitor lets you track all the activity happening with your NSGs. You can see what traffic is being allowed or denied, the rules that were applied, and any potential security events.
So it's like having a detailed security log that tells us who tried to access our applications, whether they were successful, and which security rules were triggered.
Precisely. This information is essential for troubleshooting network issues, detecting suspicious activity, and identifying potential vulnerabilities in your security policies.
That's super helpful. There's one last topic. I'm curious about containers. We hear a lot about them these days, and I'm wondering if Azure has any specific solutions for securing containerized applications.
You're right. Containers are becoming incredibly popular, and Azure has a dedicated service for enhancing their security and observability, Advanced Container Networking Services, or ACNS.
Okay, ACNS. Azure seems to have a specialized security service for just about everything. But seriously, what is ACNS and why is it important for container security?
ACNS is specifically designed for Azure Kubernetes Service, or AKS, which is Azure's managed Kubernetes offering. It provides advanced networking and security features that address the unique challenges of running containerized applications in a cloud environment.
So it's like a specialized security team for our containerized apps.
You could say that. One of the key security features of ACNS is FQDN filtering in network policies. This lets you control network access based on fully qualified domain names, making it much easier to manage complex microservice environments where you have lots of containers communicating with each other.
FQDM filtering. That sounds pretty technical. Can you break it down for us non-experts?
Sure. Imagine you have a microservices application where different components need to talk to each other. With FQDN filtering, you can create network policies that say, this container can only talk to containers that have this specific domain name.
So it's like setting up very specific communication channels between containers, making sure that only authorized connections are allowed?
Exactly. It's a powerful way to control the flow of traffic within your containerized applications and prevent unauthorized access or data leaks.
This is amazing.
Yeah.
It seems like Azure has thought of everything. I'm curious, is there one thing that really stood out to you in this network security discussion? Something that surprised you or that you think our listeners should really take to heart?
You know, for me, the power of forced tunneling really hit home.
Yeah.
I know it might seem counterintuitive to route all traffic, even internet-bound traffic, through an on-premises firewall.
Yeah.
But when you think about the security benefits and compliance requirements, it starts to make a lot of sense.
That's a great point. It really highlights the importance of thinking holistically about security. It's not just about protecting individual resources. It's about securing the entire flow of data within your Azure environment.
Exactly. And it's a great example of how Azure provides flexibility and control, allowing you to tailor your security posture to meet your specific needs.
All right, let's keep that holistic security mindset as we dive into the next layer of our Azure security journey. All right, I'm back and ready to tackle compute, the next pillar of Azure security.
Excellent. Compute security is all about protecting the virtual machines, containers, and other resources that power your applications.
It feels like this is where the rubber really meets the road in terms of security. After all, if our compute resources are compromised, everything else we've talked about, securing applications, data, the network, it could all be at risk.
You're absolutely right. Compute security is critical, and Azure offers a multi-layered approach to protecting these resources. One of the most exciting developments in this area is confidential computing.
Confidential computing, that sounds intriguing. What exactly is that?
Imagine being able to keep your data encrypted even while it's being processed in the cloud. That's what confidential computing allows you to do.
Wait, hold on. You're saying we can now keep data encrypted while it's actively being used? That sounds like something out of a spy movie. How does that even work?
It's all thanks to specialized hardware and software technologies. Think of it like creating a secure enclave within the processor itself, a tiny vault where data can be loaded, processed, and encrypted without ever being exposed in an unencrypted state, even to the cloud provider.
So even Microsoft, as the cloud provider, wouldn't be able to see our data in plain text. That's a huge leap forward in terms of data privacy and security.
Absolutely. It opens up a whole new world of possibilities for sensitive workloads like healthcare data processing, financial transactions, and even handling intellectual property.
So how can we actually take advantage of confidential computing in Azure? What are our options?
Azure offers a range of confidential computing options, including confidential virtual machines and confidential containers. With confidential VMs, the entire virtual machine environment is encrypted, including the operating system applications and data.
So it's like having a virtual machine wrapped in an unbreakable encryption shield. That's impressive. What about confidential containers?
Confidential containers allow you to encrypt specific applications and data within a containerized environment. This gives you more granular control over what is protected and can be more cost-effective for certain workloads.
Okay, I'm starting to see the different use cases for each approach. But this confidential computing stuff is really mind-blowing. Are there any other security considerations for our virtual machines?
Just like any other computer system, your Azure virtual machines need protection against malware and viruses. Microsoft offers a built-in solution called Microsoft Anti-Malware for Cloud that provides real-time protection and regular scans to keep your VMs safe.
So it's like having antivirus software in the cloud. That makes sense.
Hmm.
But how does Microsoft Anti-Malware keep up with the constantly evolving threat landscape?
It's constantly being updated with the latest threat intelligence from Microsoft's vast security network. And because it's integrated with other Azure security services like Microsoft Defender for Cloud, it can receive alerts and updates in real time.
So it's not just a standalone antivirus solution. It's part of a larger interconnected security ecosystem. That's reassuring. What about managing encryption keys and other sensitive secrets for our virtual machines?
Azure Key Vault is your go-to service for securely storing and managing keys, secrets, and certificates. Think of it as a digital vault with multiple layers of security and access controls.
So instead of hard-coding sensitive information into our applications or storing it in plain text files, we can store it securely in Key Vault and access it as needed. That sounds much more secure.
It is. And Key Vault integrates with other Azure services, so you can use it to manage keys for things like data encryption, virtual machine disk encryption, and even certificate management for your web applications.
It's like having a central security hub for all our sensitive information. That's a huge relief. But what about protecting our data and applications against accidents or disasters? What if a virtual machine crashes or a storage account gets accidentally deleted?
That's where backup and disaster recovery come in. Azure Backup is a simple and reliable way to back up your virtual machines, databases, and other Azure resources. You can easily schedule backups and restore your data to a previous point in time, ensuring business continuity in case of unexpected events.
So it's like having a time machine for our data. That's a huge weight off our shoulders. But what about disaster recovery? What if an entire Azure region goes down?
For those scenarios, Azure Site Recovery can replicate your applications and data to a secondary region, allowing you to quickly fail over to that region in case of an outage.
So it's like having a backup data center in the cloud, ready to take over if needed. That's essential for mission-critical applications.
Absolutely. And Azure Site Recovery can even automate the failover process, minimizing downtime and data loss.
Wow. Are there any other best practices we should follow for compute security in Azure?
One crucial best practice is to keep your systems up to date with the latest security patches. Azure makes it easy to apply patch updates to your VMs and other compute resources, ensuring that you're protected against known vulnerabilities.
So it's like having a digital immune system for our compute resources, keeping them healthy and protected against attacks.
Exactly. And don't forget about the importance of network security. Make sure your virtual machines are connected to a secure virtual network and that you're using network security groups to control traffic flow.
Right. We can't forget about all the network security best practices we discussed earlier.
Exactly. And finally, remember that security is a shared responsibility. While Microsoft provides a secure foundation for your Azure environment, it's ultimately your responsibility to configure and manage your compute resources securely.
That's an important point. We can't just rely on Microsoft to do everything for us. We need to take an active role in securing our own environment.
Absolutely. And remember, security is an ongoing journey, not a destination. The threat landscape is constantly evolving, so you need to stay informed, be proactive, and continuously adapt your security strategy to meet the challenges ahead.
Well said. We've covered a lot of ground on compute security, and I'm feeling much more confident about protecting our virtual machines and other resources in Azure. But we still got one more pillar to explore: identity.
Identity is arguably the most important pillar of all. It's the foundation of security in any environment, especially in the cloud.
Okay, I'm intrigued. Why is identity so crucial for cloud security?
It's simple. If you don't know who has access to what all the other security measures we've talked about, network security, data encryption, vulnerability scanning, they're practically meaningless.
That makes perfect sense. So let's talk about identity in Azure. What are the key concepts we need to grasp here?
It all starts with having a strong identity foundation. In
Mhm.
Azure, that foundation is Microsoft Entra ID, a comprehensive cloud-based identity and access management service.
Okay, so Microsoft Entra ID is like the gatekeeper to our Azure environment.
Right.
What kind of security features does it offer?
It provides a wide range of features, including multi-factor authentication, or MFA. This adds an extra layer of security by requiring users to provide multiple forms of identification when logging in, like a password and a code from their phone.
Right?
Strong password policies. Microsoft Entra ID can enforce strong password requirements such as minimum length complexity and regular password rotations. Conditional access policies. These allow you to define granular access rules based on user identity, device location, and other factors. For example, you could restrict access to sensitive data from unmanaged devices or from certain geographic locations,
Yep.
role-based access control, or RBIC. We've talked about RBAC in the context of data and compute security, but it's also a core feature of Microsoft Entra ID. It allows you to grant granular permissions to users and groups based on their roles within your organization.
Right.
And identity protection. This uses machine learning to detect and alert you to suspicious activities related to user accounts, such as impossible travel or unusual login patterns.
Well, that's a lot of features. It sounds like Microsoft Entra ID is a real powerhouse when it comes to securing identities in Azure.
It really is.
Yeah.
And it's constantly evolving with new features and capabilities being added all the time.
Okay, so we've got this robust identity management system in Azure. How does it all tie into the bigger picture of securing our entire cloud environment?
Microsoft Entra ID is deeply integrated with all the other Azure services we've discussed today. You can use it to control access to storage accounts, virtual machines, web applications, databases, and more. It's like the glue that holds all the security pieces together.
So instead of having separate identity and access management systems for each service, we have one central system that governs everything. That makes a lot of sense.
Exactly. It simplifies identity management, reduces complexity, and strengthens security across your entire Azure environment.
Wow, we've covered an incredible amount of information in this deep dive into Azure security. It's been a whirlwind tour, but I feel like I've gained a much deeper understanding of how to protect our applications, data network, and compute resources in the cloud.
I'm glad to hear that. And remember, this is just the beginning of your journey into Azure security. There's always more to learn and explore, and the threat landscape is constantly evolving.
You're absolutely right. Security is an ongoing process. We need to stay vigilant, be proactive, and continuously adapt our security strategy to meet the challenges ahead. But with Azure's robust security features and Microsoft's commitment to security innovation, I feel like we have a strong foundation to build upon.
I couldn't agree more. Azure provides a powerful set of tools and services that can help you build a secure and resilient cloud environment. And with the right knowledge, skills, and mindset, you can confidently navigate the complexities of cloud security and protect your most valuable assets in the cloud.
I want to thank you so much for joining us today and sharing your expertise on Azure security. It's been an incredibly insightful and engaging conversation.
It's been my pleasure. And to our listeners, I encourage you to continue exploring the vast world of Azure security. There are a wealth of resources available, including documentation, training courses, community forums, and more. And don't be afraid to experiment. Spin up some VMs, play around with NSGs and Azure Firewall. Get your hands dirty and see how these security features work in practice.
That's the best way to learn. And remember, security is everyone's responsibility. By understanding these fundamentals and staying informed, you can help create a more secure cloud environment for everyone.
Couldn't have said it better myself. Thanks for joining us on this Azure security journey.
Until next time, stay curious, stay secure, and keep on learning.